Hi everybody. My name is Mutwana Babantu. Let's get started. So we have a question right here. So the question they say, look, this question number 5. A roller coaster car. Oh, so this is a roller coaster car. This one, that's what they're talking about. Like if you can see even without reading the question, we see this car goes all the way down and then goes up. This is height, but when it started, it was 10 meter, and then it's gonna come all the way. But let's read the question. We don't want to do assumption. So now they say here, a car of mass. Oh, so we have a mass. So what I'm going to do, I can write all this information aside. So we have a mass of a car, which we have 20 kilogram with the engine switch off. Okay. So the switch off the engine and then let it go slide along ABC. So it's going to travel along this track ABC all the way. But they switch off the engine. So it's like a roller coaster. Okay. Now, which has rough surface. Okay. So now this car is going to travel along track. This track, I mean this path. But this path they say has a rough surface. Means if it has a rough surface, means we must have a friction force. Okay. At point B, the height means when it's here is at the height, but when it starts is 10 meter, and then which is what 10 meter above. Oh, okay. So let's say at point A, 10 meter, and then the speed of a car is 4 meter per second. Oh, so when it's here, the speed is what is 4 meter per second. Point B at height, when it comes all the way, here is at height, but they say the speed of the car is 2 meter per second. See, when it's here now, it change to 2. It will start 4, it went all the way, because look, it's going to decrease, and it's inclined up, it's going to decrease. Now, let's say point A to B. Okay, during this motion, see, point A to B has the energy. Oh, so the energy change from this point here to here is just what 3.4 joule to overcome the friction, because there's going to be friction force. So to overcome the friction. Now, what is the question? Now let's say first define the consecutive force. What is a consecutive force? Okay, so consecutive force, look, remember this object is going to be passing through this path here all the way. So now consecutive force, just a second. My apology. Okay, just a second, Femi. Okay, so now we say, okay, they say what? Define what the consecutive force. What is a consecutive force? Consecutive force, okay, these, okay, look, this object is going to be passing here. So this object, the work of an object is going to depend on the path. You see? So consecutive force, the force is non-consecutive. So the force always is non-consecutive only or in a situation whereby an object depend on the path taken. Okay, so only when this object depend on the path taken, means this path which is gonna take, then the energy which is gonna be conserved is gonna be non-consecutive force. So we can simply say non-consecutive force, non-consecutive energy, force. So the non-consecutive force, so a force is non-consecutive, a force is non-consecutive, the force is not, oh, my handwriting is bad, okay. So we say a force is non-consecutive if the work does on an object the work does on an object depends on the what? On the path taken. So for that case, the energy is non-consecutive force. You see what I'm saying? Or you can just say, oh, the energy is non-consecutive. Or you can simply say, if you don't want to say that, okay, let me just say quick because the definition is simple. We want to go to the calculation, which I can do very, very quick in a few minutes, okay? Or if you don't want to say that, you can say, okay, so a force is non-consecutive, okay? Or you can say if a force, or you can say force is non-consecutive, the force is non-consecutive if the work the force is non-consecutive if the work it does in a moving object in moving object if the work it does in moving object in moving object in moving an object around closed path closed path is non-zero. Is non-zero. So that's it. So that's the definitions. I think you understand what I say. We say the work done doesn't it depends on the path taken, right? So that's it. See what I'm saying? Now let's go to the question now. Or you can just Google it, or you can just find it from the book. That's gonna be easy. Now let's go to the actual question, which is very, very crucial that we think we want. Okay, now let's go to the question here. So in the question here, they say, look, they say calculate the change in kinetic energy of the car that traveled from point A to B, or from point A to B. Change in what? In changing kinetic energy. What is kinetic energy? Kinetic energy equal to half mass times velocity square. You see what I'm saying? That's how you get the kinetic energy. So that's how you get your kinetic energy. Simple like that. So kinetic energy equal to half times. So now they say change in kinetic energy. What does that mean? So change it. So what does that mean? Whenever you have a kinetic energy, you must have a mass and you must have a velocity. So only when an object is moving is when you have a kinetic energy. Means velocity must be involved. So if there is no velocity, let's say you're standing. If you're standing means your kinetic energy equal to zero because you're going to say a half. Okay, let's say you have a 20 kilogram or 50. You're going to say 50, which is the mass times velocity. But are you standing? So means you're not moving. Your velocity equal to zero when you square. 0 square equal to 0 times 50 equal to 0 times a half equal to 0 means your kinetic energy equal to 0. You don't have a kinetic energy. But for this case, this object was moving. So that means let's find, they say change in kinetic energy. So we're going to say, okay, change in kinetic energy that represents change equal to kinetic energy final minus kinetic energy initial. But what is our final for this case? Our final choose at B because they say find the kinetic energy from A to B. So kinetic energy at B, which are final, minus kinetic energy at what? At A, which was initial, means when an object is started. So we're going to say this same as say, what is kinetic energy? Half mass, our mass, we know our mass equal to 200 kilogram mass, okay? And then we say what? Velocity. But our velocity final choose 2. So you're going to say velocity at B minus what? A half. Mass is going to be the same mass because it's the same objects from here to there. A half times m times what? Velocity at A, which is initial, how it started. So now we say, okay, so these are constant. A half and m is constant. A half and m is constant. So we can factor out and say mass. A half and m is constant. So we can factor out this. So we're going to be left with what? Velocity at B square minus velocity at A what? Square. So for that case, we can substitute the value because we know all the value. Velocity at B we know is equal to 2. Velocity at A we know equal to 4. See? So now simple. So we're going to say, okay, our kinetic energy equal to half our mass equal to 200 kilogram because it's given right here. That's our mass. Excuse me. Our mass is given straight away, this one here. Mass equal to 200 kilogram. Okay? So now we say then, substitute. Velocity at B equal to 2. So it's going to be 2 square mean this is 2 square, and then we minus velocity at a equal to 4. This one right here, 4 square. So we can plug all this in the calculator. If you plug in the calculator, this is going to give you negative 1200 what? Joule. 1200 never mind, 1200 what? Joule. So this is our change in kinetic energy for this case when an object move from here all the way to there. But why our kinetic energy is negative, just in case? Oh, we know why it's negative, because look, this object start with a bigger velocity and they end up with a smaller velocity. So, but anyhow, if we take kinetic energy, which is going to be smaller minus bigger, we're going to have a negative. That's why our kinetic energy what is negative, and we measure what in joule. See, that's a unit of kinetic energy. So the second part here, we're done with it. So that's our kinetic energy. So I can just simply say my kinetic energy I know, so we can just fill up right here. So our kinetic energy equal, but you need to show your solution. All of it must be shown. Kinetic energy equal to negative 1 joule. But there's something very, very important, right? Whenever you have an energy, if it's more than 1000, divide, change it to kilojoule, just like a gram. It's not good to say 2000, 20,000 gram. The best way to say this, just divide by 1000, so it can be coming in kilogram. So this is going to be 2 kilogram. So same here. See, same with this. This stuff is more than 1000. So divide by 1000. So this is going to give us what? 1.2 what? Kilojoule. Oh, so it's 1.2 what? Kilojoule. So for that case, this stuff here is like a negative 1.2 what? Kilojoule. Same here, negative 1.2 kilojoule. So this is the change in kinetic energy from A to B. Now let's go to the next one. So now I have to make a space here so we can erase and find the change in the kinetic energy. We got the change in the kinetic, not finding, we just got it now. We already have it. Now we go to the second question. Okay, second question is way more, no, it's not easy, it's just complicated, but it's doable. Look, they say here now, okay, use the energy principle, calculate the height or height. Oh, so they want us to find the height. Okay, so now I want to show something very, very important, right? So you can use this formula here. This formula is very, very crucial. I want you to know. I'm gonna go straight and use, so just a second, where's my formula at now? Oh, this one here is very, very important formula, this one. So say change in what? In work done equal to change in kinetic energy plus change in potential energy. That we can represent potential. Some other books, they say what? Potential energy is a PE. So the same thing. You can say change in kinetic energy plus change in potential energy. See? Now, let's go back to our question. So going back to our question, see? Let's go back to our question. So going back to our question, they say here, all right, find the energy, find the calculate height. Meaning they wanted to find what? This height. See? Height. So I'm going to use the same strategies. Okay, so now change in work done. Change in work done equal to change in what? Change in kinetic energy plus change in, you can say PE, or you can write like that. Some books, they say change in, like I say, is a potential energy. So don't say, oh, what is this now? It's the same thing. You see? So now we're going to say, okay, now we go. So it's okay, change potential energy. Do you know change in potential energy? Oh, they give us here. Where is that? Look, they mention here, they say from A to B, this is the energy that used to overcome the friction. Oh, because remember there was a friction here. So to overcome, to come all the way, there's going to be changing, but work done. Work done change. It means a work done. See? See what I'm saying? So these are work done to over. So these are work done given. So my work done I do have. Now changing kinetic energy, I already have. Oh, I can get it. Okay. So change your work done I have already. So I can say, okay, change your work done. I'm fine with the change your work done. So I'm not gonna stress. Change your work done I know. Which equal to, I know, equal to 3.4 10 times 10 power 3 equal, Okay, changing kinetic energy. But I remember from here to there, we have it already. Changing kinetic energy, we had, which is negative 1.2. But do not use this as a kilojoule. Use the one which is in joule. So I'm going to say changing kinetic energy equal to 1, 2. So then joule in the width plus, let's go in plus. So we plus changing potential energy. Changing potential energy. What is potential energy? Potential energy equal to mg times height. Means mass times gravity times the height of an object. For example, if you have something like this inclination, let's assume, and let's say there's no height, remember, let's say you walk from here and you walk all the way to there, and they say this equal to 4-meter height. Fine, and they say your mass, my mass, let's say this is Mtwana here. So Mtwana's mass equal to, hey man, I got big weight, I'm a big man, almost 90 kilogram. See? So I feel ashamed now to mention my weight. 89 kilogram. 89 kilogram. So now we're going to say now, if we want to get potential energy change in potential energy, I'm going to say change in potential energy equal to potential energy final. Potential energy final. So I'm going to say mgh final. Because remember, mass is going to be the same. I have the same kilogram. If I walk from here all the way to the top, my mass is going to be the same. My weight is going to be the same. Gravitational force we know is 9.8. It's not going to change. The only thing is going to change is what is height. That's what I say the height final minus what? Minus what? M G H initial when you started. So now we are saying now, we're coming back to the question, don't worry, right? So the only difference, these are the same. So we can say equal to mass times gravity. Mass is the same, which is 89 kilogram. Gravity is 9.8. The height is changing because it was no height here at the ground, but here is 4 meter when I'm on top here. So I'm going to say 4 meter minus my height initial. There was no height when I started from here. So changing, because you must start with the final minus initial. So if I want to get the potential energy from Twana, now I'm going to say this equal to mass is equal to 89 times gravitation, which is constant, 9.80. 4 minus 0 equal to 4. And then this is going to give you my joule. You're going to put in the calculator and get the answer. So change the potential energy. So the change in potential energy only, you must have a height. If there's no height, meaning, that's why we say here the potential energy at initial equal to 0. Because look, what is my mass? My mass equal to 8.9. 89 kilogram times gravitational 9.8. But when I was in the ground, means it was 0. So everything potential energy, when there's no height, means there's no potential energy. So potential energy depends on the height, while kinetic energy depends on the velocity. So now we're going back and finish up our question because we want to get the height. Okay. So coming back here, we're going to say, what is a potential energy? A potential energy initial, we say we have here. Excuse me. Changing kinetic energy we have, because we did calculate already this one. Now, changing potential energy. Changing potential energy, we say potential energy final, but a potential energy we say is mgh, mg. So we're going to say, look, we're going to say mgh final minus mgh initial. Okay? So we're going to say now, mass and gravity is common. So mg, okay, h final minus h initial, because m and g are common. So we factor them out. Mean these are common here. So we factor them out. So we left with these two. See? So I can simply go and plug it in there. So I can say, okay, now mg h final minus h initial, close your bracket. So the next thing now what we're going to do, we're going to just simply substitute the value. Remember, you want to get what? H. See? But look here, man. I love this. Okay. H final. Do you have H final? 22. But do you have a H initial? Do you have a H initial? What do we want? What do we want now? Look, they say calculate the height. I'm wrong. You know why I'm wrong? Because we want to find, excuse me, look. I didn't read the question careful. Find the height. But height for what? For A to B. They did not say B to C. So it's more of here, A to B. Because the question here based on A to B. So height final, what is height final for this case? The height final equal to B, height initial equal to A. So I'd rather say here what? is final and initial, but let me be specific. My final equal to B, my initial equal to A. So for that case, now I'm going to see, so I have to find, okay, plug it in everything. So this is going to be 3.4 times 10 power 3 equal 3, family. Okay, negative 1, 2, plus mass. What is a mass? Our mass is given equal to 200 kilogram. And make sure your mass must be in kilogram. If it's in gram, make sure you change to kilogram. 200. Okay, gravitational 9.8. Okay, height initial equal to 10. When you started, it was 10 minus height final. Oh, the height in final equal to height equal to h. Oh, so we have everything. What we have to do, we just have to make it the subjects of the formula. H is the subject of the formula. So it's easy. So what I'm going to do, plug in the calculator, take this to the left, and say 3.4 times 10. 3 plus 1, 2, because this is going to go to the left. And then we say equal, multiply these two, it's going to be 2. Okay, 10 minus h, you just say 10 minus h. So what we're going to do now, I'm going to divide by these throughout. So divide by 20, 9.8 on the left, and then 200, 9.8 on it. Right, this and this cancel. So it's going to be h minus 10 here. See? So h minus 10. Oh my God, I made a mistake here, sort of family. Look. This is supposed to be h final, h at b. What is h at b? Is h minus 10. Because h final, b equal to height minus 10. Okay, so it's height minus 10 and not other way around. I was wrong because this is the final, this is the initial. When finally h. Okay, my apology. I hope you understand. So now we're going to say now here. Okay, so we're going to say now, let's get height. It's easy. So we're going to say make height this up means this 10 is going to go over. So we're going to say this equal to 3.4 times 10 power 3 plus 1,200 over 9.8. And then we plus, this is going to come over, is going to become plus 10 equal to height. So plug in the calculator. If you plug in the calculator, this is going to give you 8.88 meter. Oh, so now we have this height. Oh yes, we have. So height here, we know. Our height now we know, my brother and sister. My beautiful sister and brother. Okay, let's go. So now we're going to say our height equal to 8.88 meter. Now what do we want now? So we have the height, we have the energy. We go for the last one. Okay, let's go for the last one. So for the last one is easy because look. So we have the height, you have everything here, right? Okay, let's go for the last part here. Drink some water a little bit. Okay, now let's get the last one here. Quick. Let's go erase, please. Sometimes this eraser can be. Okay, so we have it already. So now let's go. Look, the last part here, they say, okay, now for 5.4, but we have to read face and top here before we answer this question. See, before we answer this question, we have to read here. Now let's say on a reaching at B, so now we're here at B. The car's engine is switched on because remember when you started, they say they switch off this one. If you look carefully, it mentions somewhere. Must travel along the track at the surface below. Okay, there's a place where it say the switch off. Okay, see, just a second. Yeah, I mentioned somewhere where the engine was switched off. A roller coaster must have engine switch off. Yes, that one right there. My apology for me taking time, but I think you understand. Now they say now at point B, when they reach here, now they realize like, this guy is not going to go on top. Because there was inclination, so it was just like a roller coaster. But now from here to there, we're going to have to switch on the engine so it can move quick to the top. So they decided, you know what, let's switch on the car in order to move up to the inclination to reach point C so that they can reach at point C. Okay? So then means here we're going to involve a lot of things. It's going to be engine involved, friction forces is going to be involved. Now, let's go. So now what do they want? The car travel at what? 15 seconds from B to C, 15 seconds. So we have a time, 15 seconds. And another things, they say which is what? We have a height here, which is 22 above the ground. Here today is 22. Now, while moving from point B to C, the car travel for 15 seconds and the constant speed of, so the speed here is constant, equal to what? To 2 meter. 2 meter per second. See, meter per second. Second. Okay, I mean right here. So equal to 2 meter per second, and then okay, so this is 2 meter per second. Now, okay, 2 meter per second. So now we say, this is my apology, right? Okay, something just fell. Okay, so now they say an average friction force. Oh, there's a friction force here. Oh, what does that mean? Let me explain to you well about the friction force here. Look, if you have something like this, let's say this inclination, let's say an object moving to the top. This object moving to the top. Let's say I'm pulling this. Or let's say I'm pulling or force applied. It could be force applied. Let's say force applied means let's say you pull it. I'm pulling it. Or if you don't do, let's say force of engine. For now, for here is not car, so we can say force applied. So if this object moving to the top means the friction force always opposes. So this is going to be friction force or friction kinetic. If it's moving, you say friction kinetic. But if it's stationary, we can say just a friction stationary friction force. So now it's just let's say friction force in general. So since this object moving up, so the friction force always oppose. You see, it's always oppose the motion of an object because this object is accelerated to the top of the inclination. So friction always opposite. Now, let's come back here. So let's say here, but remember for a car, let's say for a car. Say this is a car. If this car is moving up, means the force which is making moving up is the force of engine. So for that case, now friction force is going to be opposing friction force. See what I'm saying? So now for this one here, so this car is going to be moving like this. It's going to move like that. Something which is moving up is force of engine. So friction force can be opposing. Opposing direction. Let me use another color here. Just see. So friction force is going to be moving opposite direction. Like let's use okay. Let's do this. That's a friction force. So we can represent. Let's say use FF. Friction force. So this is the force of engine which is moving up. Now what do they say here? They say, let's go to the question. They say now friction force we have equal to 50. Oh, friction force is force, people. So if it's force means it's going to be in Newton. Now calculate the power delivered by the engine to move the car from B to C. Oh, because this car is moving because of the engine. So we want to find out the power delivered by engine. Okay, now let's go. So the car, so we're going to use similar formula like the one we used before. So the formula say okay, so we say change in work done. See, the work done is changing kinetic energy. No, let's do this because now it's going to be two things. Now it's not only work done. From B to C we have two things: work done and also work done. You see what I'm saying? And also we must have work done by friction. Means work done by the car and a work done by friction force. Equal. So in the same formula that we used before, which was saying like this, look. Let me write like this. So the formula was supposed to be the same, like okay, work done equal to change in kinetic energy plus change in potential energy. You can use U or PE. Now, But in a work done here, it can't just be only work done. We have two things involved. What are the two things involved? Look here. Engine, so work done, see, by engine plus work done by the friction. Because it's going to be engine involved with a car which is moving up, also it's going to be friction force involved. Equal to work done by kinetic energy, which you're going to say equal to a half mass. So since a half and mass is going to be constant, so we can say, okay, look, it's going to be a half mass final, but a final is going to be at C now, means it's at here, C square minus, because it's going to be B to C minus a half mass times velocity initial at what? At B. Here is at B. So what happened? Look, this and this is a constant, so we can take out a half in half out, mass and mass out, but this is difference because this is V at C and V at B. Say V at C square minus V at B square. So I can write this here because you need to show all the works. So I have M V at C, which is final, minus V at what? At B, plus now changing potential energy. See? So changing potential energy now, we're going to do the same thing. From what? From B to C. So from B, we know potential energy is a half. Okay, potential energy is what is that? So say, okay, so I want to get this one, right? So say now, change potential energy equal to half mgh, but H at C minus mgh. H at what? H at B. So this let me say mgh at C means is here minus H at B, because these are constant here. That's why I take them out. So then I'm going to write this here because this is changing in potential. So instead of this, I was just showing you how it's done, but in a shortcut, you can just write M, G, and then H at C minus H at B. Close the bracket. You see what I'm saying? So now, what we can do now, we can substitute anything we have. Okay? Now we can substitute everything we have. So now, let me find the work done of engine, because if I get the work done of engine, then it's going to be easier for me to get what? The power by engine. Let me get the work done first. So I'm looking for this now. See? I'm looking for that. Now we go. So I'm going to say now, okay, so everything here I have. These one I have. All of these I have. Okay? But we don't have this. So let me find each one separately. So work done by friction, because I'm going to find, okay, work done by friction. Let me do separately equal to, what is the work done by friction? What is the work done by just work done? Look. Excuse me, sorry. Not work done equal to force times displacement times cos of angle. Amen. You have to memorize this. Never forget. That's a work done of anything. Okay? So now, for this case here, look. I'm going to say, do you have a friction force? Oh, yes, we have. Friction force equal to 50 Newton. They gave to us this one. 50 Newton. See? They gave us friction force equal to 50 Newton, which someone hear this. So friction force, I got. But it's a friction force. So look, let me say it again. These are just normal work done. But for now, we want to get what? Work done by friction. Means we must find the friction force is the work done by friction, not just normal work done. So we're going to say now, because look, this object is moving up by engine. Also, there is a friction force which is opposing. That's why we have to put them together. So we're going to say now, look, do you have a friction force? Yes, we have. Equal to 50. Do we have a distance? No, we don't know the distance. The distance means they refer to this distance here. This distance here, the object moving. Do you know that? No, I don't know. But I can get it. You know how I'm going to get it? Look, we know always velocity equal distance over time. Velocity I have, because it's given. They say velocity equal to 2 This one here. So I can make the substitute distance equal to velocity times time. Velocity I have and time I have. What is my velocity? My velocity equal to 2. From here to there is what is? 2. Constant velocity equal to 2. Oh, so it's going to be equal to 2 times time. Time they give us equal to 5 seconds. 15, where is it? Where is it? Yeah, 15 seconds. Is 15 or 2 seconds? Time equal to 2 seconds. Yeah, equal to 2 seconds. So say velocity. What is the velocity? Velocity equal to 2. No, it's not 15. Hold on. I'm wrong here. No, it's here, man. I'm confused two things. No, that's not time. It's not time. It's 15 seconds. Sorry. Here, look. Is 15 seconds. From B to C is 15 seconds. Oh, so equal to times 15 seconds. Or equal to 30. So the velocity distance from B to C equal to 30 meter. Okay, so for that case now I'm gonna say, okay, I'm gonna say now, look, so this let me say friction force times this is equal to V times T, because we know how it come about, say velocity equal to distance times time, and then to get distance means VT equal to distance. That's why distance equal to VT, because I have a velocity and time. If I had a distance from here to there was no need for me to do all of this, you see. So now I say cos. So what is the angle now? That's a tricky part. So I was like, man, I don't know, I'm always confused about the angle. Easy. Look, but remember, it's for friction force. This object is moving this way. Look, family, if you have a Cartesian plane in a trig, right? We go back to the trig. So which angle is this? Let me use the color here quick. So which angle this? This is 0 because that's how you started. But the more you move, like let's say here it could be 45, here it could be 90, here it could be 135, here it's going to be what? 180. So if you can look careful, this stuff, if you look, this is like a 0. Like the way objects sliding on this surface is like a 0 degree, 90, but a friction force is opposing. So friction force moving this way. So mean, look, if this is 0, this is 180. So friction force is angle 180 because opposing the moving an object of an object. So for this case, since we want the work done by friction here, which is here, because we want to get this work done by friction, so the angle is going to be what? 180, because it's like it's opposing this direction, opposing, not that direction. That's to say what? 180. So for that case now, we have a friction force. What is a friction force? So now I'm calculating this one, right? And then we're going to substitute. Our friction force equal to 50 times. So you can even say here not in exam, not. Or you can say but. And then you calculate this on a side face, and then you work it out. But I show you working exam. Okay, the trick is write everything. Do not write aside, because the more you write everything in exam, that's how you get more marks. So I'm going to say times velocity. Do I have a velocity? Oh, yes. Our velocity, where's the velocity? 2. This one, 2. Times time, 15. Cos of 180 equal to -1. See? So you can plug in a calculator. This is going to give us -30, -1,300, -1,300. Okay, cool. So this is going to give us what? -1,500. See? Yeah. Oh, yeah. -1,000. If I made a mistake, you can just check it clear, because I'm trying to go fast now. Let me try 50 times 2 times 15 times -1 times -1. Oh my God, times -1. Yeah, -1,500 joule. So this is going to be work done by friction. So we have work done by friction. So now the next things. So now show you this work, right? So we can substitute all of this and all of this and finish up. Easy. So now we're going to say now, we can plug it back. -1,500. So then I can say, okay. So now we say work done by engine plus negative. That's a -1 equal. Now we come here, half mass mass equal to, okay, look, I like this. But they mention here, look here, let me show you. They say here, constant speed. So if the constant speed, meaning here, velocity final, look, it's going to be, look. What is the velocity final? It's going to be the same because constant speed means when you start here, it's going to be 2. When you finish here at C, it's going to be 2. Means it's going to be 2 squared minus 2 squared, which is going to give us 0 here. Because 2 squared equal to 4 minus 4 equal to 0, 0 times a half equal to 0. So show it in exam, but we know it's going to be 0. Plus mass equal to 200. Okay, and then times G equal to 9.8 times height final. So height final we have, what is height final? 22. And then we minus, okay, what is the height initial? Height at B, we have equal to 8.8, this one here. At B, 8.8. Okay. So what we're going to do then, we can just calculate it. What we want to calculate, we want to get what? Weight of engine. So it's easy to get a weight of engine here. So I'm going to say, this simple say, so okay, so weight of engine, plug everything in the calculator, this is going to give you 0, and then plus, put these all in the calculator, and then take this 1,500 over, and then add them together, and then work done of engine is going to be, okay, the work done of engine is going to be 215 20 what? Joule. Oh, so this is work done of engine, okay? So work done of engine, we have it now. But the question does not ask for work done of engine. They want power of engine. So I can write here aside, say, okay, we're not done yet, right? This is just a work done of engine. So work done of engine equal to, because they want power, so we're not done, 2721 5.20 joule. So how are we going to get power of engine? To get power of engine is easy. Okay, so I can just simply raise here, because I don't need a space. So power of engine now, power of engine equal to, I like this. How we get power of engine? Power of engine equal to work done of engine. Okay, simply power of engine equal to work over time, work done over time. That's what you should know. Power equal to work done over time. So for this case, we want to get what? Power of engine means it's going to be work done of engine, which we just got it, work done of engine over time that the engine was using from here to there, from H to there. Okay, so we have everything. What is work done of engine? This one right here, 27 21 5.20 joule over time. How long did it use? 15 seconds. So now, if this time in a minute, make sure you change it to second, okay? It must be in a second. So for that case now, we're going to say finally, power of engine equal, plug in the calculator, that's going to give you 14.3335 watt. Because you measure power using what? Watt. So now that's how you do the question. But look here, fam, if you face time in this program, what you have to do, just come here, subscribe. You know, it's very, very important to subscribe, because when you subscribe means every time when I upload the video, you're going to get the automatic notification. So come here, show me some love, show me support, okay? And then do not forget to click the like button and share this video. Make sure you click the like button, because when you like it and you subscribe, meaning it's going to reach more students, okay? So now, so for that case now, I believe you have learned how to do this question from beginning to an end, okay? So this responds to a student from a different part of the world. To be specific, this question was sent by a student from South Africa, the place in KwaZulu-Natal. So now, thanks a lot for your time, and you know, student from KwaZulu-Natal, from all the provinces of South Africa. I do this from deep down my heart so you can learn and grow. Thanks a lot, and I'll see you soon. Peace in the mouth.